Here we're going to look at some normal distributions. All of the normal distribution problems from this lesson is a part of your Blackboard assignment, so I'm actually going to do examples of another one. You should be working with normal distributions in your 152 class as well. So hopefully this is just really helping you understand normal distributions a little bit better. So a normal distribution for a continuous random variable can have any value for its mean, mu, and any positive value for its standard deviation, sigma. The letter x is used to indicate a point on the normal curve. So we can use norm.dist to tell us the cumulative area to the left of any point on the curve. Now remember, in Excel, it only does to the left. So if you ever want to do to the right, you have to do 1 minus norm.dist. Your formula will be norm.dist, and then you'll have your x value, your mean, your standard deviation, and true. We will always use true in norm.dist. Now, if you ever want to do, so there's your formula to the right. Remember I said 1 minus, but if you ever want to do this between area, you will have to do norm.dist, and then you'll do your larger value, mean, standard deviation, true, minus norm.dist, your smaller value, mean, x, your mean, standard deviation, and true. So let's look at just a couple of examples here, and I'm going to draw them out for you. So I have that we're going to just suppose that the most recent statistics test had a mean of 85 and a standard deviation of 3.7. And for each of these examples, we're going to just draw the area or draw the picture, just do a little sketch, and then find the area indicated. So what would be the probability that a student scores below 70? So the first thing I'm going to do is write that as an inequality. So the probability that a student scores below 70. So we have a normal distribution because we should know that test scores are usually normally distributed. It will usually state that in your problem. So here we're going to look at, okay, if I'm sketching this, I have a mean of 85. So that means I'm falling somewhere down here and I'm doing below. So I'm going to sketch below. Now I have to do my formula, so I'm going to do norm.dist because this is below and reading to the left, so I don't have to worry about that 1 minus. And then you're going to have your x value, your mean, your standard deviation, and true, or 1. So I'm just going to use a 1 here. They both mean the same thing. So that's your formula you would put in Excel, and then Excel is going to give you the decimal, so 0.0002517. So you can try, what is the probability that a student scored below 80? You can pause the video here and give this a try in Excel. Now let's look at another example. What if I have, what is the probability that a student scored above a 90? So the probability that a student scored above a 90. Now, if you notice that in binomial distributions, it did matter if it was less than, greater than, less than or equal to, greater than or equal to. It does not matter in normal distributions because they are continuous. So I can use 90 as my value here. So we're looking at above. Now this is a little bit different, right? Because we've got a shaded to the right section. So we need to make sure that we do equals 1 minus norm.dist. And then of course your values are going to be 90, and then your mean, I should have sketched that up here for you, so 85, standard deviation of 3.7. So 85, 3.7, and 1. And when you enter that in Excel, you should get 0.0883. So why don't you try this number 4, the probability that a student earned higher than a 60. So what is the probability that a student earned higher than a 60? You can pause the video here and then come back when you're ready to view the answer. So if you notice here that 60 is more than 3 standard deviations below the mean, so most of all of our data is going to fall there. That's why we have 1. So now let's look at ones that may have a range of values. So what would be the probability that a student made a B on a test? So what is a B? A B is 80 to 90. So we're looking at the probability that a student gets between an 80 and a 90. So what would this look like? So because we do have this range of values, you do need to do the difference of, you're going to do the larger minus the smaller, because if you think about it, what we're doing here is we have to do this whole area up to the 90, and we have to subtract this smaller area up to the 80 to give us that blue area that I have shaded there. Okay, so I'm going to do equals norm dot dist 90, 85, 3.71 minus norm dot dist 80, 85, 3.71. Again, remember that 1 means true, so you could use either thing there. And you should get 0.8234. You may also see this as what is the middle 95%? Where you've got to remember that when you're thinking about middle 95%, so this is like another example here, I'm going to think, okay, this is my 95% here in the middle. So what is that going to leave me with? Well, that means I have 5% split between these two tails. So that means 2.5 here and 2.5 here. So you would have to do up to this first part. So let me shade it yellow. That actually, this mark right here is actually 97.5%. And this little tiny part down here would be 2.5%. So all of these range problems can be done. You just have to think about how they need to be completed. So I'm going to give you an example to try on your own on the next slide. And it will be, what is the probability that a student made a C on a test? So we'll do that, and then you can pause the video and see the answer. So here we are looking at what is the probability a student made a C, and a C is a 70 to an 80. So the probability 70 less than x is less than 80. And now we can figure out, again, this is going to be a range. It's going to be on that lower half. So 70 to 80. So this will be equals norm.dist 80, 85, 3.71 minus norm.dist 70, 85, 3.71. And Excel should give you 0.0883.